In this video, we're going to consider the following sequence given by un is the square root of n plus 1 minus the square root of n. We will use the squeeze theorem to prove that the limit of un is 0 as n goes to infinity. Okay? If you want to prove it, you can just go ahead and start doing it. So an easy and helpful hint is that try to use the conjugate for this one to make it easier. Okay? So let's solve this one. Okay? So we know that the n plus 1 is bigger than n. Okay? So when we take the square root of both sides, okay? So we're going to have the square root of n plus 1 minus the square root of n bigger than 0. That means that un is bigger than 0. Okay? So that means it's always positive. But you can also think of it this way. So the square root of n plus 1 is bigger than the square root of n by a bit. So this one is making the difference. So we can just look at this one and say this result. But this is the algebraic proof of it. Okay? Next, we're going to see that here for n bigger than 1, we're going to see that we can use the conjugate here in this case. So we're going to use un is just the square root of n plus 1 minus the square root of n. So we're going to multiply both top and bottom by the square root of n plus 1 plus square root of n over the square root of n plus 1 plus the square root of n. Here using our algebra, okay? So here, so think of this one as x, this is y, this is x, this is y, and using the result that x plus y times x minus y is x squared minus y squared. So here our x is this one. So we're going to have the square root of n plus 1 squared minus the square root of n squared over square root of n plus 1 plus the square root of n. Okay, this is positive, so we're going to have only n plus 1 minus n over the square root of n plus 1 plus the square root of n. So by the end, we're going to have 1 over the square root of n plus 1 plus the square root of n. Okay, now we're going to see that we're going to do some bracketing here. So we know that the square root of n plus 1 is bigger than the square root of n. So when we add the square root of n to both sides, we're going to have the square root of n plus the square root of n is the square root of bigger than the square root of n plus the square root of n, which is 2 square root of n. When we flip, okay, this one is going to be less. Okay, when you invert, okay, that's because that's what we need here. Okay, notice that we need this one inverted. So we're going to have the square root of n plus 1 plus the square root of n is less than 1 over 2 square root of n. Okay? So now what we can say is that we have un is between 0 and 1 over 2 square root of n. Okay? Now this is where we can use the squeeze theorem, sorry. So this is a sequence that's squeezed between a sequence that's 0 and this one here. Okay? So remember that, I don't know how you call the squeeze theorem in notation, but this is un is between two sequences, an and bn. Okay? If this one goes to L as n goes to infinity, and this one goes to L as n goes to infinity, therefore this one, it's trapped, it's squeezed between these two, and therefore its limit is going to be L. But here, this one goes to 0, so we divide 1 by this square root, so n gets big, it's going to go to 0. So therefore, the limit, okay, the limit of this one is just 0, and this one is just 0. Therefore, the limit of un is just 0. Okay? So this is a simple application of the squeeze theorem. Therefore, here we can write now that we can say that we proved that this result here using the squeeze theorem, that this one goes to 0 as n goes to infinity. Another idea is that we can use logic, okay? So when n gets bigger, when you take the square root, okay, these two guys, they get close because they are only different by 1, okay? So, and 1 in square root, so they get very, very close, and therefore their difference is 0, okay? So when we take n to the infinity, they're gonna be 0, okay? This is the logical sense of it, and this is a proof using the squeeze theorem, okay? And I think that's all we need for now, okay? So one quick check, we did everything, we explained this one, I did explain this idea here, and I think that's all we need. And do you have any questions or comments? Please contact me or put them in the comment section. Thank you very much.